Okay, today we're talking about 8.3, the tangent ratio. If you were in class, what we did is we created right triangles in GeoGebra. I gave you a certain angle measurement, and then you recorded the angle, or excuse me, the side opposite that angle and the side adjacent to that angle. And the adjacent side is never going to be the hypotenuse. We're actually going to get into that a little more in the next section. So just to kind of give you an idea, and again, if you were in class, you have this. So if we have a right triangle, if this is the angle that I'm going to be talking about, then this would be the side opposite. Okay? And then this, the other leg of the right triangle, is the adjacent side. Okay? And then we have the hypotenuse over here, but for the tangent ratio, we're not really going to be using that. So the tangent is the ratio of the opposite leg to the adjacent leg in a right triangle. And again, we kind of did an exploration with this. Okay? And every angle has a unique ratio of opposite to adjacent. So it doesn't matter if the triangle is as big as your school or small enough that it fits on the eraser of your pencil. The ratio of the opposite to the adjacent leg, if you divided the opposite by the adjacent, those lengths, and the angle was 46, you're going to get 1.0355, for example. And when we did this in class, we kind of did that. And we can also work it backwards, that if I told you, for example, that I took the opposite side and divided it by the adjacent side, and I got 1.8040. And you said, okay, well, let me figure out where that ratio is. Okay, here's that ratio. And so if this is the ratio of the opposite to adjacent, then that means the angle measure is 61. Okay? And you're going to see how we're going to use this. This can also work in your calculator. This entire table has been programmed into your calculator, actually to an even more exact value than the whole number degree angles. So I have this up here. This is kind of how they used to do it before they had the nice calculators, but your calculator should do this too. If you don't see this, it'll look like SIN or COS or TAN. TAN is the one we want. If you don't see those on your calculator, look for TRIG, T-R-I-G, somewhere in your calculator, and there's probably a menu where it has these as well. All right, so oops. I'm going to talk through these. I have the answers here as well. So for the top two triangles, I asked for the tangent of A, the tangent of B, the measure of angle A, and the measure of angle B. So when I say find the tangent of A, what I'm asking for is from angle A, what is the ratio of the side opposite to the side adjacent? So here's angle A right here, and I go opposite that, that's 2, and adjacent, remember adjacent is never the hypotenuse for our trig functions, is 7. So the tangent of A, what's the tangent of A? It's 2 over 7. Okay. And then for the tangent of B, again, when they're saying that, they're saying what is the ratio of the opposite side to the adjacent side from B? So I go opposite, I get 7, adjacent is 2, so my ratio is 7 over 2. Now to get the angle measures, we're actually going to kind of do what we did with the book. So tangent of A is 2 over 7. If you take 2 and divide it by 7 on your calculator, you'll get 0.2857 blah, 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 blah. Okay, so using the table, if I look under tangent, because that's the ratio I'm looking for 0.2857, or really, really close to it. Okay, right here looks like it, 0.2857, so that means that angle A must be 16 degrees. Okay, now the way to input this into your calculator is use what's called the inverse tangent. So if you have a menu, if you have a tangent button, you might have to push second tan. And what this is telling your calculator is saying, calculator, I'm going to give you a ratio. I'm going to give you the light yellow number, and I would like you to give me the dark yellow number, the gold number. So if you type this exact thing into your calculator, you will get, if you round it, to 16. Now, you could do the same thing for angle B, where we could say the inverse tangent of 7 over 2. 7 over 2 is 3.5. So again, if we look through here, 3.5 makes it about 74 degrees. Again, I found 3.5 in the tangent column and then went over. But the other way is we know two angles now, 90 and 16. You could have subtracted them from 180 and got angle B that way. Over in this one, I have two sides of the right triangle. I'm missing the third, so I use Pythagorean theorem to get this side over here. Again, the tangent of A is up here, hard to see. So I went opposite, 8, to adjacent, which is 15. Tangent of B, opposite. So in that case, it's 15, and adjacent was 8. If I want the angle of A, I did the inverse tangent. Inverse tangent, again, is saying, telling your calculator, I'm giving you a ratio, please give me the angle. Okay, and you can see my answers here. Also, feel free at any point in time, if you want to just pause and kind of work through the blank answers from your notes and then come back and check your answers, you can do that too. All right, over here I have to find x. Now it's a right triangle, important to start. I can't use Pythagorean theorem because I don't have two sides of the triangle. And it's not a special right triangle. It's not a 30, 60, 90 or a 45, 45, 90. So that's where I'm going to use my trig functions. So the tangent of 24 is x opposite over adjacent 20. So I know that no matter how big or how small the triangle is, when I divide the opposite side by the adjacent side, I should get a certain number. And you can even see that here. It should be 0.4452. Okay, so I set up the equation, the tangent of 24 equals x over 20. To get x alone, I multiplied both sides by 20, and then I typed in my calculator this exact thing here. So when you say tangent of 24, the calculator is giving you the ratio of a 24-degree angle opposite to adjacent. And then we usually tell you round it to the nearest tenth, so the side would be 8.9. All right, so I solved a few more here. I'm going to just talk quickly through them. But again, feel free to try it on your own and then come back and hear the explanation or just look up and check your answer to see if you got it right. So the tangent of 35 is opposite over adjacent. So tangent of 35 equals x over 10. So I'm kind of wondering what number, when I divide it by 10, will give me the tangent 35 ratio. Okay, so here's tangent 35, 0.70002. So what number, when I divide it by 10, will give me 0.7002? Okay, so I did 10, multiplied both sides by 10, and I get 7. 7 over 10 is really close to 0.7002. All right, and again, I would be using your calculator. I can't easily bring one up on my screen. I don't have the right stuff on my computer to do that. Okay, so over here, two ways to do this problem. I did it in blue and I did it in red. If you use a 21-degree angle, tangent of 21 degrees equals 30 over x, or what number can I divide 30 by to get the ratio I need? I multiplied both sides by x, and then I divided both sides by tangent 21. That's where I got here. Now, if you don't like the x on the bottom of the fraction, that, Mrs. Renfrey, I'm worried that kind of confuses me. Don't forget, we know this angle up here too. All I have to do is 180 minus 90 minus 21. I get that this angle is 69. So tangent of 69, if I did this angle, opposite is now x, adjacent is 30, multiply both sides by 30, you get the same answer. So it doesn't really matter which way, but sometimes I have some people that don't really like when the x is on the bottom, so they'll work it from the other angle. Over here, notice the location the variable changed. It's now in an angle position. So I need to find the angle. So I'm going to say inverse tangent this time, saying calculator, I'm going to give you the ratio instead of the angle. 8 divided by 5. So I'm giving you the light yellow number and asking you to give me the gold. Okay, and so I did the inverse tangent of 8/5. 8/5 because it's opposite over adjacent from y. And over here, inverse tangent of 6 over 8. Opposite of y is 6, adjacent is 8, and I got 37 for that one. So that concludes the notes here, and hopefully that'll help you to work on the problems.